She was not mine. You went down. No, I did.
No, I didn't.
I didn't. Sorry.
Okay, now we come to occurrence of metals. Where do metals occur?
Beneath the ground.
On the surface of the earth.
Crust.
Alright, now I go very fast. Now, for the extraction of metals, you use ores and not minerals. You use ores and not minerals. What's the difference between ores and what's the difference between minerals?
Minerals are directly found open and ores
This
are
is not the explanation I gave you last time. And how many years ago there was last time? How many years ago, how many centuries ago did I teach you the difference between minerals and ores?
ores have impurities.
Did you look through my notes? No. I'm like an idiot, keeping on explaining to you children, but you're not making any attempt to go home and read what I've taught you. What is it?
It has a very high percentage of the particular metal in it and can be profitably extracted.
Yeah, so you have to say what is an ore. An ore contains the metal in high concentration. It will give us the metal easily, readily, and cheaply. Minerals also have high concentration of the metal, but they don't give you the metal easily, readily, and cheaply. Hence, therefore, we will use ores and not minerals. Okay, now, for the extraction of metals, you have got various, give me the pen. Okay, I got it. So you have got various stages. The first stage is, this is the metallurgy. Metallurgy. What is metallurgy? Metallurgy is nothing else but the different method that you use to obtain the metal from the ore stage right up to 99.99% of purity of the metal. Okay, that is called metallurgy, all the different stages. The very first stage is extraction of the ore. Extraction of ore. Second one, concentration of dressing of the ore. Dressing of ore. Third one.
Ma'am, can I turn on the AC?
Don't turn on the AC, put on one or two fans. Third one is converting ores to oxides. Okay. Then 4, reduction of oxides to metals. And fifth one is purification of metals to 99.99% purity. Okay. All right. Got that now? First is extraction of the ore. Now what happens is, suppose I'm an industrialist. Suppose I'm an industrialist and I want to get copper. So I will have to go and find out exactly where the copper is available. So for that we'll get a zoologist. Geologist. Who will go and tell me, here there are a lot of reserves of copper. So now what am I going to do? I'm going to take big huge earth movers and I'll take all that earth because it contains copper and I'll bring it onto my factory premises because I have to get my copper. So therefore, after all that is taken out, I have got so much of earth. Okay, so that is one part of it. I've extracted it, taken it from the source. And they're in huge lumps, huge boulders, huge rocks. I will have to make them into smaller pieces, smaller pieces. And finally, I've got to make them into sand, pulverizing. It's called pulverizing. I've got to pulverize these huge boulders into
Small pieces.
absolutely tiny bits. That's called pulverizing. That is all in the extraction. But that pulverized ore has got lot of dirt in it. So therefore it has to be dressed. What's the meaning of dressing? What happens to you when you go to dress, when you dress up? You make yourself presentable. Or
Concentration.
concentration or dressing of the O. Now what means dressing up? So why is it called dressing? When you dress up, all unwanted things you take out, and you take out only what is necessary, what makes you look nice. Same thing here, all what is unnecessary we throw out, and only what the clean O, the nice O we keep for ourselves. And when we take out the unwanted, take out all the unwanted material associated with that metal, it is called concentration, because so much of mud and so much of dirt, finally we have taken out, and we have concentrated, we have only this much we have got. That's called concentration. Okay. Now in English, when we say, give me, if I ask you to go and get me a dressed chicken, this is English now. What will you get? A dressed chicken means what?
The one which is marinated.
No.
Dressing
Clean
it's
properly,
Huh?
clean properly and cut
Meaning
pieces.
a chicken whose feathers have been plucked. Because you can't have a chicken with all the feathers on the dining table, can you? Does it look nice? Does it look dressed? But when you pluck out all the feathers, that looks fresh, that looks presentable. But actually, you're undressing the chicken, not dressing it. See the English language. Okay? Actually, you're taking out all the feathers, making it naked, and yet you're calling it dressed. Hello? What do you say?
Impurities.
Nothing. The feathers are plucking out. Do you eat chicken? You eat chicken? They all eat chicken. So therefore you know exactly how you have to eat chicken. You pull out, in fact today we pull out the skin also. We don't really want the skin because underneath there are all fat cells and we can't tolerate them. So chicken whose feathers have been plucked and taken out and made to look presentable is called dressed chicken. Though we had actually undressed it. Okay, fine. Anyway. So now we have got a lot of that ore, which has been crushed and made into powder. Now we have to study that ore and see what is the nature of that ore. If that ore is water soluble, then we use something called hydraulic separation. Hydraulic means water under pressure. Hydraulic separation. What do? We take that ore and we place it on a bed, a big bed. And the bed has got a sheet. It has got tiny holes in it, like a chalni. Chalni मालूम है ना?
The one
Chalni.
holds
Yeah. It's like a tea strainer. That is the steel plate which is on the bed. And we spread this ore on top of it. And from a height, we just focus water at high pressure on that ore. And that ore keeps on turning around because the pressure, if I put high pressure water, you also will turn. You also will turn with the pressure. The water can make a hole in your body. Okay, so if you can really, it turns round and round, and all the unwanted material gets passed through the holes and collects under the bed. And only this much of the ore is on the top of the bed. That is called concentrated ore. And what is under the bed is called gangue. G-A-N-G-U. Not gangue, not tongue, but tongue. Gangue. G-A-N-G. That's called gangue. What is gangue? The unwanted material associated with the ore is called gangue. All impurities. Okay. So that's how that is when the ore is water soluble. Suppose the ore is iron ore. Then we have got to use magnetic separation. Now what do? Is we use an electromagnet. Electromagnet has got two rods. One rod is kept fixed. This is fixed. This is moving. This moves. Okay. Now over this belt, both the belt, there's a rubber belt. There's a not a rubber belt, sorry. It is a metal belt. It's a metal belt. And that metal belt keeps on moving when you put on the switch. This is fixed and this is moving and the belt is moving and the belt is moving and the belt is moving. Now while that is moving, it has converted the area around it into an electromagnetic field. Okay? So now what happens is from top, again the ore is thrown on that belt. But it's moving, and the ore is falling. All the unmagnetic particles are flung outside the magnetic field. and all the magnetic particles are thrown inside the field and they form a nice big mound in the field, and the unwanted material is thrown outside and forms a mound outside. That again, that is called magnetic separation. That is when the ore is magnetic. The third one.
With the pulverized ore.
All pulverized. You can't use blocks. No, not at all. You have to use very, very, very fine powder. Then the last one is froth flotation process. Froth flotation process is only meant for sulfide ores. So remember one thing. Hydraulic is meant for water soluble. Magnetic is meant for magnetic or iron ore. And froth flotation process is meant for sulfide ores. So the ore is in the sulfide form. You've got a huge tank. And in that tank, we have put the sulfide ore. Over that, we have added water. And over that, we have added pine oil. Pine oil. Pine oil is eucalyptus oil. All oil from pine trees, coniferous trees, deciduous trees, all that we give pine oil. Now, why pine oil? Because pine oil has affinity for sulfide particles. Affinity, like sulfide particles. Pine oil likes sulfide particles. Now, through that tank, we've got fountains through which air is passed. When air is passed in that, don't you think this whole thing will turn round and round and round? It will turn round and round. And then we've got green wood poles. What do you mean by green wood? Ordinary wood, but green in color. Why green in color? Because those green poles are fresh. They contain a lot of oxygen. Not brown wood. Brown wood is dead wood. You don't use dead wood. You use fresh wood. And that is also rotating. So that keeps the whole contents of this tank agitated. And while it is getting agitated, all sulfide particles get stuck up to the pine oil. And the pine oil is in bubbles now. It comes rising up to the top. On every bubble, there's a speck of sulfide ore. Like with a chalni, you take it out, you scoop it out. Okay? All right? And you get your sulfide ore separated. And the rest of it is discarded. That's called froth flotation. Froth. That is called face to both and a face in froth flotation. Floating. Understood? Don't repeat this, huh? Huh? No. Understood now, all of you? Okay. Okay, then after that, so we finish concentration. Next step is converting into ores, oxides. Now, these ores that we have got, they could be in the form of sulfides, they could be in the form of oxide, they could be carbonates, nitrate, they could be of any form, depending upon what metal we are using. Okay? Now, copper is, I was talking about copper. Copper is very, very reactive because it's very, very low in the reactivity. So it will always be found in the form of sulfides, oxides. Sulfides and oxides. Alright? So that is lower reactivity metals are in the form of sulfides and oxides. As far as gold, silver, and platinum are concerned, it will be found in the form of gold, in the form of platinum, in the form of silver, because they are not reactive. You will find them in the native state. As you go higher, that is above hydrogen, you will have those metals which are called middle reactivity. They are found in the form of sulfides, oxides, and carbonates. Middle reactivity. Alright? Middle reactivity is sulfides, sulfides, oxides, and carbonates. Very low reactivity, only sulfides and oxides. And very high reactivity, you'll find them in all compounds. Sulfides, chlorides, nitrates, carbonates, bicarbonates, everything, because they're highly reactive. They will react with anything and everything and give a umpteen number of compounds. So, whatever the form is, we have to convert that ore into an oxide. Why? Because you get the metal very easily from the oxide. From the sulfide, very difficult, very expensive. From the carbonate, very difficult, very expensive. From the nitrate, very difficult, very expensive. You've got to convert every compound, whatever it is, irrespective, into its oxide, because it is from the oxide form that you get the metal very easily. So if it is copper sulfide, how will we convert the sulfide into oxide? We have to convert it into oxide, convert the sulfide into oxide. How will we get it? How will we do it? How?
Sulfide into oxide.
Yeah.
Roasting.
By heating with excess of oxygen. Excess of oxygen. This is called roasting. It is called roasting. Heating. This is heat. Excess of heat. So what happens is copper combines with oxygen to give you copper oxide, so you got your oxide. And sulfur dioxide is liberated as an impurity. If it is a sulfide. If it is a chloride, again with oxygen, okay, if you again you get with oxygen, then you're going to get your oxide and you're going to get your chloride. Okay, but it's mostly sulfides. Metal reactivity. Metal reactivity is in the form of sulfides, carbonates, and oxides. Oxide, if it is copper oxide, it's already copper oxide, you don't have to change it at all. But if it is middle reactivity, either sulfide or carbonate or oxide. If it's a sulfide, you have to do roasting. If it is carbonate, suppose it is copper carbonate, how will you get it? How will you get copper oxide?
Specific amount of oxygen. Specific
You
amount of
have to calcinate it, meaning heating in absence
or limited.
of oxygen. So there already oxygen here. You have to put more oxygen. Okay, so what you're going to get
So
now?
they
You get
need the
copper
ores in vacuum. They need the ores in vacuum.
in a vacuum. In vacuum. Therefore, copper oxide plus carbon dioxide is the impurity. So you got your oxide.
Then you heat more.
Huh?
Then you heat more to
Yeah.
get the pure
So
substance.
so you got that now? So in the case of sulfide ores are roasted and carbonate ores are calcined. So what's the difference between roasting and calcination?
Roasting means
Excess of oxygen,
Absence.
absence of oxygen. Okay? Sulfide ores are roasted, carbonate ores are roasted. Sulfur dioxide is an impurity, carbon dioxide is an impurity. Let's give an example. Copper sulfide, copper carbonate. 4 points, 2 marks. Followed? Want me to repeat? Understood that? So now you have converted all your ores to oxides. Now we have to take away the oxide, that is reducing of the oxides to metals. If you take away the oxide, yes or no? Only then you get the metal. And again, that metal is not 99% pure. You get the purity here. So how do we do it? If it is metals of lower reactivity, when we say lower reactivity, it means that the metal has combined with oxygen very weakly. Very low reactivity. So the bond is very, very weak. So just by rubbing the metal, we can set the oxygen free and we get the metal. Just by rubbing it. You break the bond and the oxygen goes and we get the metal. No need of heating, just rubbing. If it is rubbing, meaning you're using a paper, you have sandpaper. Sandpaper you have, or you have got a rough felt cloth.
So magnesium ribbon which is there.
Follow? Not magnesium ribbon, it's magnesium oxide which you rub off. You rub off the oxygen. You get the shiny metal. Okay. Now, in the middle reactivity, what happens is you have got oxygen there. Middle reactivity means they are strongly reactive. That means the bond is very, very strong. Bond is very, very strong. So then you can't use rubbing. You got to use heat. If heat doesn't work, then you have got to use pressure. Okay? Then you've got to use, otherwise you've got to use a reducing agent. Hydrogen. Metals. All metals are reducing agents. All metals are strong. They get oxidized, but they're reducing agents. Reducing agents get oxidized. Oxidizing agents get reduced. Okay? The phenomenon is opposite the agent. Okay? So, in middle reactivity, since the bond is very, very strong, you have to use heat to break the bond, or you may have to use a catalyst, or at times you've got to use a very, very strong metal. Now, very, very important here, you come to something called the thermite process. Okay. Now, if you are taking a particular compound, like say, for instance, FeSO4, sorry, Fe2O3, sorry, it's oxide, no? We made it already an oxide, isn't it? I can't use sulfate.
Yeah.
I have to use an oxide.
And
Plus aluminium, metal. Reheat it. Okay? You get Al2O3 plus you're getting iron. Now, this mixture only, with mixture, aluminium plus Fe2O3 is called thermite.
It produces molten iron.
Huh?
It produces molten iron.
It produces,
molten iron.
yeah, thermite. It's called thermite. Same type of reaction you have. MnO2, manganese dioxide, plus aluminium. You are getting Al2O3 plus Mn. But this is not thermite. Why? Why is this not thermite and why is this thermite?
Because heat, is it related to heat?
No, why?
It doesn't produce molten iron.
Because?
It doesn't produce
No,
molten
no,
iron.
no. Why?
Can you repeat?
Why is the mixture of Fe2O3 and aluminium called thermite and this mixture is not thermite?
Because of heat.
I just told you, huh? I told you only Fe2O3 plus aluminium with thermite. That word thermite can be given only to this mixture.
Because heat is released.
No, heat is released everywhere. This is aluminium, this is aluminium. This is Fe2O3, this is MnO2. But Fe2O3 plus aluminium is called thermite. This is not thermite. Yeah, this mixture. Why is it called thermite? Because it's got iron oxide in it. Why is this not called thermite? Because it does not have aluminium oxide.
Iron oxide.
Iron oxide. That should be your answer. It will come to you in the form of fill in the blanks, so perhaps in natural colors. Why is it called thermite? Because this is a mixture of iron and aluminium. Why is it not in thermite? Because this does not have iron. It's the magnesium.
Also, why
Manganese.
in absence of iron they haven't mentioned thermite?
Huh?
Why is the
Because
thermite
this
not
thermite
used?
is only, what is your name?
Goran.
Gaurav. You're only because, but he also could have been called Gaurav, but you are called Gaurav. Because that is your name.
Yes.
This is its name. Specific name given to it. This is, you can't call it thermite. This is not the name of thermite. This is why I can't call him Gaurav because he's not Gaurav. I can't call it thermite because it's not thermite. Thermite is this and this and this only. Now, this particular reaction is very, very important because they say give one reaction which is exothermic, which is thermite, which is displacement, and which is oxidation and reduction. This reaction, see here, this is exothermic reaction. This is also exothermic reaction, correct? Exothermic reaction. So this is exothermic reaction. Because plenty of heat is given out. Plenty. That's why you get it in the molten state. How? I'll tell you. Exothermic reaction. Second one, it is called thermite. Thermite, because it is Fe2O3 plus aluminium. It is called displacement. Displacement, because aluminium is displacing Fe2O3 from this. Aluminium is more reactive than iron. Fourth one, what is the fourth one? First, second, third one. And fourth one,
Reduction and
it
oxidation.
is a reduction and redox reaction. Redox reaction. Why? Because this gets oxidized and this gets reduced. Can this satisfy all these 4 points? Can the second equation, this is equation number 1, this is equation number 2. Can second equation number 2 satisfy all these 4 points?
No.
Why not?
Because the second one is not thermite.
Very clever boy. You're paying attention. It's not thermite. But this it will satisfy. This it cannot satisfy. So thermite is this and this and this alone. This is called aluminothermite process or aluminothermy. Now, what exactly happens here? See, for aluminium thermite, for this thermite process, that means you're using iron. Thermite means iron. You cannot repair a crack in the railway line. Can you carry that railway line and bring it to the factory? Can you carry a full bridge and take it to the factory? But you can bring the factory to the bridge. You can bring the factory to the rails. Now see that. The rails are like this, correct? And there's a crack on them. Now, you know you have a wheelbarrow. The wheelbarrow is placed on that rail. Okay, over the crack. Over the crack. So it is placed this way. Not this way, but this way. The handles are this way. In that wheelbarrow is Fe2O3 powder. Okay? And 2 sticks of aluminium are put inside. They're called fuse. You know, when these people are doing the welding, they put those people and they have got the rods that give out the fuse. That, like that, is aluminium. Okay? And that whole wheelbarrow is shut. Okay? And the fuse is lit. And at night, that aluminium rods are burning and burning and burning. It's an exothermic reaction. It has gone and converted Fe2O3 into Fe. Okay? So all the iron, the heat is so very, very hot that the iron is now in the form of liquid and it is collected in one little box underneath. So whole night the reaction is taking place. Early morning the fellow will come and with a long rod he'll open up the lid and let the iron pour over those cracks. Understood? And that's how the cracks are sealed. Then of course it's taken away and then with the help of that leveler, these carpenters have got that randa, they call it, they put all the extra, like that, they take on all the extra iron. Because if extra iron is kept on the rails, the train will derail. It has to fit into the grooves. So the extra iron is cut off. And the rails are used for travel. This is how aluminum thermi is used for industrial purposes. Clear? Alright? So we finish your reduction into metal. Now this metal that we get here is reduced now using your metal. Metals are strong reducing agents. So either for middle reactivity, either you use high heat or you use very strong reducing agents. Strong reducing agent, you will use metals only because metals are very, very strong reducing agents. Okay. Now we go to very high reactive LS. They're so reactive, and they have got hold of that oxygen so tight that you give it heat, it will not break. You give it heat and pressure, it will not break. You give it heat, pressure, and catalyst, it will not break. They're so stubborn. So when they're so stubborn, what do? We give them the electric shock. That means, in other words, we pass electricity. Only electricity will break the bond. Electrolysis. With electrolysis, with electricity, okay, we break the bond. Oxygen is set free. Oxygen goes on to the anode, and the metal goes to the cathode. That is high reactive metals. So high reactive metals are the metal oxides are obtained only by electrolysis. Middle reactivity, the metals are obtained only by reduction, by heat, by catalyst. And the last lower only by reduction. Okay. Now we have got the metal, but that metal is not 99.99 pure. Now we have to get it 99.99 pure. 99.99 pure metal can be obtained only by electrolysis. How do we do it? Suppose you have got a voltmeter. It's called a voltmeter, a tank. A voltmeter. This is voltmeter. Voltmeter. Okay. In that voltmeter, we have got electrolyte. We've got the electrolyte. This is electrolyte. Electrolyte. What is the electrolyte? It is a salt of the metal that is to be purified. So electrolyte is salt of metal to be purified. Purified. If it is copper that we are purifying, this has to be copper sulfate. Correct or not? So this will be blue in color. Then we have got the cathode. The cathode is a thin rod of pure metal, which is to be purified, pure metal. This is the cathode. Cathode is your positive, okay?
No, ma'am, negative.
It is negative. Cathode is negative.
Anode is positive.
Cathode is negative. Thin rod of. And anode is a very thick rod. This is anode. Thick rod of impure metal. Thick rod. Now both of them are connected to an outside source of electricity. Sorry. Both of them are connected to an outside source of electricity. Now electricity is passing from the anode through the electrolyte and it goes to the cathode. So when it passes through the electrolyte, it is broken up into copper and sulfate. Correct? Now, suppose two copper ions from the blue solution have gone and stuck up here. Two ions from here will go here. Directly from here, it won't go here. It goes from here to here, from here to here. Okay? So if two from here go here, two from here, ions will go from here into the solution. Therefore, the solution will always be blue in color. The solution will always be blue in color. Okay? If the ions were not replaced, after some time you find that the solution becoming colorless. But this remains always blue in color. And then you will find that this is becoming thinner and thinner and thinner. And this rod becomes thick and thick and thick of purity.
Layers and layers of.
Yeah, and there are big holes. All dirt has come out from here and accumulated here at the bottom. All dirt from this impure and this is called anode mud. Anode because it's fallen at the bottom of the mud. And why mud, not dirt, but mud? Because sometimes it contains metals far more superior than the metal that you have purified. Look at copper. Copper is associated with silver, gold, and platinum. That is how copper is found in the earth. So you will find traces of gold, traces of silver, traces of platinum. Therefore, this mud is not destroyed. It is useful. And you've got your thick rod of cathode and thin rod of anode. Then you replace the rods. This is how you get your purity of metal. Okay? That's all. Now, alloys and all that you can read, no?
Yes.
Huh? That you read. Yes, come on, read. Can't take here. Whose book is this? Huh? Now keep that book closed and go to sleep over that book. Don't open it at home. Don't read. Ask for another lecture, which I'm not going to take. And what? Why are you laughing? How many children are there in your class?
There are more four.
No. In otherwise also in class, normally. Only 10 children.
11.
In school, you are.
No. Here,
Here, 11.
For maths, there are 11.
11, then chemistry for
For
science.
science, there are over 12. For 3. And more 3. So 8.
Small class. English
Eight.
also, English only there.
English
4, 5.
4, 1, 2, 3, 6.
All of you are from rank.
He is not from Rand.
You're from?
Amity.
I'm like you.
What are alkali metals?
Alkali metals are those metals which from hydroxide get solved in water. No, alkali metals are sodium and pressure. To give alkalis.
Lithium.
हाँ, क्या है?
कुछ नहीं ना.
You supposed to read it.
I was telling that just now you told
You were just
About
told
the
about
alkalis.
alkalis.
हाँ. Look, you, according to UT classes, NKT sir has done this chapter.
No.
I mean, sir has done
Ma'am,
this chapter.
MKT sir has only done one chapter,
Ah.
which is chemical reaction.
And acid bases
And
also.
that too.
Yeah, and acid bases and so that
And
too it was
Amit
not
sir,
very
he had come
But
from
that's very,
not
not
very clear.
Like we can understand each other.
so then who came after that?
Amit sir.
So,
Then he had got, I think,
2 hours.
Yeah,
3 days he had
hours.
got. 3 days he had got. And 2 of the classes he finished carbon and
Carbon
its
and
compound.
compound.
That was not so clear. And
Then
then-
another teacher came, not here.
no,
no, Amit sir only. Then in the last class he had just revised in one in 1 hour he had done metals and non-metals, and other hour he had revised.
Then
acid
other new
bases.
teacher did not come and teach you.
Directly you.
Huh?
Directly you give.
Then I came.
Yeah.
Now after me, who's going to come now? Who's going to come?
Mala. Moment.
That's my shoe. I told you to read, no?
Yes.
Huh?
Are you was learning?
I don't think those teachers who probably were strict enough to smash you people properly. So you must have been over enjoying yourself in the classroom.
Uh,
You are paying attention to what the teachers are teaching you in the classroom.
Yeah.
Of course, you'll say yes.
Amit sir was very strict.
Huh?
He used to smash.
Amit,
This was smash you. How you smashed him?
like he smashed and
How you smashed him? Ah, he beat him.
Like he was, we don't want to discuss that.
He was.
He locked me out and then
Keep your hand to yourself. You think I'm stupid or what? So he hammered him. Smashed him.
he had put some conditions, so he heard that conditions and then he
You lose your lost your mind or what? Huh? पागल हो गया क्या?
so like he was also out in the break time,
Ah,
and so he was washing his hand and I was out, so he saw it, he took him out and
that day.
Only I'm interested. The teachers are not sure.
SPD, no.
Huh?
SPD, biology.
Yes. Yes, Samita. What happened to her?
She did smash anybody, but like she used to scold everyone.
Not everyone.
Not everyone.
To the sense.
She's very strict. Good teacher. Okay, all the teachers are obviously very good.
Uday sir is also good.
Huh?
Uday sir.
Uday, yes. What Uday Singh?
Yeah, well, he's also good at teaching.
Physics.
Physics.
Sudha.
Used to teach us.
Who?
Sudha.
Sudha. Okay, Sudha.
And English also.
Huh?
English.
English. Bernadine.
Yeah.
Strict.
So what's
Not that much.
if you don't respond in the class, you just stay quiet, then she'll answer in the class.
Yeah. All of you didn't show me that the bonding between magnesium and chlorine, no? You should think.
Rachel, you showed us.
I think this girl. Check. You have to show it like this, no? See, like this is the do. Ah, okay. This you copy from somewhere.
No,
This I should. Where's yours? You should. अभी कर रहा है वो लड़का.
I just put the other one.
There's the thing, atomic number of chlorine. What is it?
287. 70.
Have you started studying your student for the exam seriously?
yes.
You go to school, still go to school? At your
Yes.
or you stay at home or you only stay at home?
In school because my percentage
Huh?
is down.
If you have doubt. Mad monkey.
अभी 80%
Recently, before today is only 4 credits from the school.
That's MIT.
All from the 10th, I think only 16, no, 16, 16 to 17 students.
How old is your school? Not very old, man.
It opened in lockdown.
October?
Lockdown it was open.
5 years.
The will of the branch. We are the second batch.
Huh?
Second batch.
Second batch. Oh. First batch.
Yeah.
It's at the 7th. You have finished learning, reading it?
Yes.
Go now?
Yes.
Time to go? Or you want to have any further difficulties you want to solve? Want to go?
Yes.
Go. Check and see whether there are difficulties, any more difficulties. Now, no more classes will be given to you all, huh?
No.
Hydrogen carbonates. Hydrogen carbonates.
Bicarbonate. Sodium bicarbonate is called sodium hydrogen carbonate. Sodium hydrogen carbonate is the IUPAC name, and bicarbonate is the commercial.
Why is it? Mine, na?
Why do I look in the dark? Oh,
क्या है?
shit. मैम ने पूछा क्या है? Bro, stop.